My name is Frank Nichtjal and I'm the Product Manager for Conducted EMC. I warmly welcome you to our webinar Updates in Burst and Search Standard. Nice that so many of you have been registered. The webinar will give you a summary of all standard changes from the last years. There are a lot of changes which have effect on the test results. You can use this webinar as an update or refresher, and maybe there are some new information for you. Let's start with the presentation. We will start with Burst. The latest edition is still edition 3 from 2012. The first Burst standard was released in 1995. Edition 2 from 2004 was a major update, which included different calibration routines, new frequencies, and different test setups. The latest version is from 2012 and is edition 3. Old burst generators used a spark gap to generate the burst pulses. Since edition 2, we have to use an electronic switch for this. We also added a new burst test frequency of 100 kHz in parallel to the already existing 5 kHz. The calibration now has to be performed with 50 and with 1000 ohm at the 50 ohm output, plus with 50 ohm at the output of the couple network. The coupling mode now is common mode, which means you have to couple all lines simultaneously. And for coupling on supply lines, the cable length is now reduced to half a meter. The edition 3 introduced a new calibration procedure to calibrate the capacitive coupling clamp by using a transducer plate. The burst pulse itself has a rise time of 5 nanoseconds and a duration of 50 nanoseconds. But for calibration at the output of the couple network, the values are 5.5 nanoseconds for the rise time and 45 nanoseconds for the duration. And they also changed the specification of the distance between the EUT and the coupling device. For tabletop equipment, it's half a meter. For floor standing equipment, it's 1 meter. Since edition 2, we have the new burst test frequency of 100 kHz. This is not mandatory to use. Users can decide if they want to test with 5 kHz or 100 kHz, or if it's specified in their product standard, then they have to use the value which is specified there. The 100 kHz is just a guideline, but honestly, it's closer to reality. The simplified circuit diagram showing the same major elements. They just exchanged the spark gap with an electronic switch. The single burst pulse is still specified with a rise time of 5 nanoseconds, measured between 10 and 90%. Duration is still 50 nanoseconds, measured between 50 and 50%. For the burst package, they newly added a new combination. The old one was a package wide of 15 milliseconds and a frequency of 5 kHz. Repetition was 300 milliseconds. The newly added is with 0.75 milliseconds and a 100 kHz frequency. Repetition is the same of 300 milliseconds. If you can calculate, the number of burst pulses per package in both cases is 75 pulses per package. That means they do not increase the pulse energy. But what is now the real difference between the old and the new one? Since this has to be measured at the couple network output, we need to compensate the voltage loss on the couple network. In fact, we have approximately 20% more energy, and we need to make sure that we really have the test level at the generator output as well as the decoupling network. That's different and gives approximately 10 to 15% more amplitude. The output voltage range for a load of 1000 ohm is specified with 0.25 kV up to 4 kV, and for 50 ohm load between 0.125 kV up to 2 kV. We have two repetition frequencies, it's 5 kHz and 100 kHz, both with a tolerance of plus minus 20%. The pulse shape, as said at the generator output, is still a 550, which means 5 nanosecond rise time, 50 nanosecond duration. Both are specified with a tolerance of 30%. And with a 1000 ohm load, it's 30% for the rise time, but in a range of -15 up to +100 nanosecond for the 1000 ohm load. Table 2 gives an overview of the output voltage values and repetition frequencies. Both frequencies 5 and 100 kHz are listed there. Since the burst generator has an impedance of 50 ohm, a load of 50 ohm will result in a reduction of 50%. When we add a 1000 ohm load, the reduction is just 5%. When we calibrate the coaxial 50 ohm output, first we have to add the 50 ohm calibration resistor. The output of the generator has a 50 ohm impedance, and the input of the resistor also has a 50 ohm impedance. In addition to that, we have a 100-to-1 divider inside the calibration resistor, plus a 50 ohm output impedance, and in combination with the 50 ohm input impedance of the oscilloscope, we have in total a ratio of 400-to-1. So if you select a 2 kV burst pulse, you can expect a 5-volt signal at the oscilloscope. The next step to calibrate the coaxial output is using the 1000 ohm calibration resistor. This one has a divider of 500-to-1 inside. In combination with the 50 ohm output plus the 50 ohm input of the oscilloscope, we have a total ratio of 1000-to-1. So when making the calibration at 2 kV, you can expect a 2-volt signal on your oscilloscope. The calibration of the coupled-decoupled network was completely unspecified before the release of the Burst Edition 2 in 2004. In the old Burst standard, we just had to measure the 50 ohm output with a 50 ohm coaxial load, and there was no calibration procedure for the output of the coupled-decoupled network. Since the Edition 2, we have to do this also at the CDN. To do so, we have to switch on this common mode. Common mode means we have to enable all lines simultaneously, which means it could be 3 lines for one-phase EUT and 5 lines for a 3-phase EUT. For the calibration itself, we have to set the burst amplitude up to 4 kV. The Edition 2 then gave us a tolerance of ±30% for the rise time as well as for the duration. The rise time and duration at the output of the coupled network is not different since Edition 3. It is ±1.5 nanosecond for the rise time and ±15 nanosecond for the duration. And you see also a change in the duration. Edition 2 gives 50 nanosecond, Edition 3 45 nanosecond. Keep in mind, this is for the output at the coupled network only. After the release of the Burst Edition 2 in 2004, there were some discussions in the committee on how to understand, how to interpret the standard. What is the meaning of common mode, simultaneously coupling, how to calibrate the generator as well as the coupled network. This was made crystal clear with the release of the Amendment 1 in 2010. This new version showed a picture with the coupled network, and all the coupled passes are switched on. Here you see the switches are closed. Each individual output then have to be measured with a 50 ohm coaxial load in a sequence. For each output, we have to measure the peak voltage and the waveform. These are recorded for each polarity. I would like to show you the calibration of the coupled network with a one-phase coupled network as an example. As the LEDs are indicating, the coupled passes are active for L, N, as well as for PE. There is a special adapter available, but we need to connect the coaxial calibration resistor to the 4mm safety banana plug. Now the first step now is to connect the calibration resistor, the 50 ohm one, to the L output. There we measure the rise time, duration, as well as the amplitude. The other two outputs are active but open for the moment. In the second step, we now change the resistor to the N output. Then now the L as well as the PE is open, and we make the same measurements. And in the third step, we change now to the PE output, and L and N is open. For all outputs, we have to measure the rise time, duration, as well as the amplitude. To fulfill the requirements of this standard, each individual output must show the transient within the tolerances as specified. To calibrate the capacitive coupling clamp, we have to use a so-called transducer plate. The transducer plate consists of a metallic sheet of 120 mm by 1050 mm with maximum 0.5 mm thickness. It is isolated by a dielectric foil of 0.5 mm. This plate then has to be put in the capacitive coupling clamp, and we need to add the 50 ohm load at the opposite side of the burst generator connection. For the calibration, we have to set the burst generator to 2 kV. The tolerances then are, for the rise time, 5 nanoseconds plus minus 1.5 nanosecond, duration 15 nanosecond plus minus 15 nanosecond, and the amplitude 1 kilovolt plus minus 200 volt. One more hint. With edition 3, we also got the specification, that means with a tolerance, for the so-called lower coupling plate. Old burst coupling clamps had a width of 16 centimeter. The two middle plates had a width of 7 centimeter plus 2 centimeter for the strip to tighten the screws. 7 plus 7 plus 2 is 16. But today, in the edition 3, we have a width of 14 centimeter. That's why the newer capacitive coupling clamps look a little different. You will not get different test results if you use an old or a new coupling clamp. The coupling capacitance is still between 50 and 200 picofarad. But the old ones are as simple as no longer according to the standard. Here you see the transducer plate. It is so thin that you can coil it. After you inserted the transducer plate into the clamp, close the clamp and tighten the screws. For connection of the calibration resistor, we use the same adapter which we use for calibration of the output of the couple network. Besides the fact that we have to calibrate the generator in common mode, we also have to test in common mode. That means that the single line testing, line after line, is not demanded anymore. Only the common mode is specified. Interesting side note. In the first edition, 1995, they forgot the 10 cm insulating support for tabletop equipment. It was specified just for floor ceiling equipment. This was added in 2004 with the edition 2. The edition 3 no longer specify the cable length between the output of the couple network to the EUT. It specified the distance between them. This is for tabletop equipment, half a meter, and for floor ceiling equipment, 1 meter. This makes life much easier, especially for EUTs having an uplifted cable entry. Now we come to the search standard. The latest version is the edition 3.1 from 2017. Similar to the burst standard, the very first search standard was released in 1995. The first real update was made in 2005 with the edition 2. But it was the edition 3 released in 2017, which incorporated a lot of major changes. Let's have a deeper look to the major changes of the Search Edition 3. In the old standard, we had two different specifications of the wave shape. It was the IEC 60060-1 as well as the IEC 60469-1. This is now corrected. In the new version, we just have one clear specification for rise time as well as for duration. The calibration of the waveform has to be done at the generator output, which is 2 ohm, plus a serial 18 microfarad capacitor. And we also have to calibrate the output of the couple-decouple networks from main supply lines. These CDNs are now harmonized up to 200 amps. We have different classes, current classes, and divided in the current range of 16 amps, 32 amp, 63, 125, and 200 amps. A higher current through the couple-decoupler network will make a higher voltage loss over the decoupling coils. That's why we now have different tolerances for rise time and duration for each single current class. Completely new is the calibration for data line CDNs. In the old standards, they were not calibrated, but now it is. We have to measure them in open circuit as well as short circuit situation. The already mentioned 18 microfarad decoupling capacitor is also used for tests on shielded cables. Shielded cables are not tested with a 2 ohm output plus this 18 microfarad capacitor. If a shielded cable is grounded just on one side, we have a different setup. Then in this case, it is not like a test on a shielded cable. It's like a test on a normal data line. And that's why we have to use a normal data line CDN for shielded cables grounded just on one side. Double insulated products, that means products without any earth terminal, are tested just line to line and not line to ground. There's also a difference to the old version. And this applies to power supply lines as well as for data and signal lines. Next one, the coupling network for telecommunication lines, which are usually tested within 10/700 microsecond pulse, is also changed. In fact, they changed the impedance of the coupling path. Lastly, they added the measurement uncertainty MU in the Annex D. In difference to the edition 2, the edition 3 now separates between line-to-line and line-to-ground coupling. Line-to-line means between phase and phase, as well as phase and neutral. The highest test level for line-to-line coupling is now 2 kV, and for line-to-ground is still 4 kV. The surge pulse is often called a hybrid pulse. This is because of the two pulses which can come from the surge generator. We have the open circuit voltage and the short circuit current with a 2 ohm impedance. We have two definitions. First is the IEC 60060-1. This one called the parameters front time and time to half. The front time is specified with 1.2 microsecond, time to half with 50 microsecond for the open circuit voltage. And it's 8 microsecond front time and 20 microsecond time to half value for the short circuit current. Indifferent to this, the IEC 64691 called the parameters rise time and duration time. The rise time was specified with 1 microsecond and duration time was 50 microsecond for the open circuit voltage and 6.4 microsecond for the rise time and 16 microsecond for the duration time for the short circuit voltage. Important to understand it that both definitions are valid and describe just one single generator. Here we find these two old definitions. First, the IEC 60060-1. The front time T1 is a time from 30 to 90% with a fixed factor of 1.67. This should give 1.2 microsecond. The time to half value is where the tangent line crosses the x-axis till 50%. This should be 50 microsecond. The second definition is from the IEC 64691-1. The rise time is specified between 10 and 90% and should be 1 microsecond. Duration time is between 50 and 50% and should be 50 microsecond. Keep in mind, this was valid for just one generator. Here we have the new definition from the edition 3. The open circuit voltage is specified with a front time of 1.2 microsecond. This is a result of a fixed factor of 1.67 multiplied with a time between 30 and 90%. The duration is a time between 50 and 50%. And as you can see, we do not use any longer a tangent line. For the short circuit current, we have to use a factor of 1.25 for the front time and the time between 10 and 90%, and for the duration we use a factor of 1.18 and the time between 50 and 50%. The edition 3 specifies the characteristics for coupled decoupled networks up to 200 amps. As you can see in table 4, this current range is divided in 5 different classes at 16, 32, 63, 125 and 200 amps. The wave shape is defined for common mode coupling against earth, and the wave shape shall be measured in open circuit as well as short circuit situation. Tolerances are increased at higher currents in the coupled network. This is due to the fact that we have to reduce the decoupling inductance. Its maximum is 1.5 millihenry, but the voltage drop is still less than 10%. Higher currents will lead to higher voltage loss over the decoupling coils. So to stay within the 10% limit, we have to reduce the decoupling inductance. Because of this, the tolerances for the wave shape is different for each current class. And as you can see, as higher the current is, as higher the tolerances are. The calibration of the surge generator has to be done at the output of the coupled-decoupled network. There are 2 different measurements. First is the open circuit voltage, where we use a high voltage probe. Second one is a short circuit current, where we use a current probe. We have to measure all possible differential mode and common mode couplings. Another important difference between edition 2 and 3 is that the waveform specification for unsymmetrical interconnection lines was completely unspecified in edition 2. Now we have the edition 3, which has a table 8, which specify the surge wave shape at the EUT output of the CDN. As you can see, it specifies the amplitude as well as the rise time and duration for the open circuit voltage as well as for the short circuit current. What does it mean for users having an old CDN for data and signal lines? Can they use it from edition 2 to 3? No, they cannot. Most CDNs, data line CDNs, which are according edition 2, are definitely not according edition 3. They need to be replaced. We also have a complete new calibration process for symmetrical interconnection lines. For the calibration, the impulse has to be applied on one coupling path only. Amplitude, front time and duration shall be measured for the CDN rated impulse voltage under open circuit conditions. The inputs for the auxiliary side shall be short-circuited to protected earth. Table 9 show you the process and Table 10 the specified wave shape. You will also find a flowchart which will guide you through the process of selecting the right CDN test method. There are 3 main questions. First is it a main or not main? Second one, is it shielded or unshielded? And third one, is it connected, the shield connected at one side only or at both sides? In dependency of your answers, you will find the correct figures which showing you the test setup you have to use. Here we have the test setup for shielded cables which are grounded at both sides. As you can see below, the setup itself isn't changed from edition 2 to edition 3. It still specifies that the EUT as well as the auxiliary equipment should be powered over an isolation transformer. The cable between the EUT and the auxiliary side have a preferred length of 20 meters. What they changed is the generator impedance. It was just a 2 ohm in the old standard, and the new one specified 2 ohm plus an 18 microfarad capacitor. For EUTs, which do not have a metallic enclosure, the surge has to be applied directly to the shield cable at the EUT side. The test setup for shielded cables which are grounded only on one side differs from edition 2 to 3. In edition 2, they used a similar setup as for cables which are grounded on both sides. But at one side, the auxiliary side, the test cable was open and not connected to the chassis of the auxiliary side. But in edition 3, the test is done as for unshielded asymmetrically data lines. In this case, the surge testing is not applied to the shield. It's just on the data line itself. And lastly, one more important change. The edition 3 introduced high-speed data line couple networks. What are high-speed lines? That are in and output lines which operates with transmission frequencies above 100 kHz, and they can have a speed up to 1000 megabit per second. You cannot use a standard CDN for data line when testing a high-speed data line, because the decoupling coils will limit the bandwidth of the high-speed data line. Another benefit of these couple networks is that these can be used for shielded as well as for unshielded cables. And this is much more easy and more reproducible than making a test setup with a 20-meter cable. So we are at the end of the slides, and I hope you found this webinar useful and there was something new for you, or at least it was a good refresher about all what's new in the burst and surge testing. As we are short on time, I will answer now just the most often asked questions. Do not worry, I will answer all of your questions after the event. One question was, does surge generator, which is according to edition 3, also covers edition 2? It will cover edition 2, but not vice versa. Edition 2 will not cover edition 3. What is the major difference between old and new burst generators? The big difference came with edition 2 in 2004. Since the pulses are now specified also at the output of the couple network, they normally have more energy and a higher amplitude. As simple as that, they were not specified at the couple network in the old standard, and therefore the test result can differ between old and new burst generators. Question 3 is, can I upgrade my old burst and surge generator to edition 3? This depends on the age of the generator. You should contact your distributor and ask if it's possible or not. He's responsible for that and he will check with our service center. To verify if an upgrade is possible, we need the serial number of the device. Okay, thank you very much for your time and hopefully we will see you within a short time. Cheers, bye-bye, and stay healthy.